For this problem, we're to find the integral of cosine of 8 theta times the cosine of 3 theta d theta. And the thing that I notice is that the angles here are different. So the 8 theta is different than 3 theta. The technique that I will use for this problem is using a trig identity. And the trig identity that I will use is our product to sum trig identity. The cosine of A times the cosine of B is equal to 1/2 times the cosine of A minus B plus the cosine of A plus B. So there's an identity for cosine of something times cosine of something. There's an identity for sine of something times sine of something. And there's an identity for sine of something times the cosine of something. So all three of these you should have with you for the exam. So for this problem, using the identity, we have that the integral of cosine of 8 theta times the cosine of 3 theta d theta. According to the formula, this is equal to 1/2 times the cosine of the difference of the two things, so 8 theta minus 3 theta, plus the sum, or sorry, plus the cosine of the sum of the two things, 8 theta plus 3 theta d theta. So this works out to be integral of 1/2 cosine of 5 theta plus 1/2 cosine of 11 theta d theta. So I've converted the product to a sum, and now the integral is fairly straightforward. The integral of 1/2 of cosine 5 theta is 1/2 times 1/5 sine of 5 theta. And the integral of this will be 1/2 times 1/11 times the sine of 11 theta plus c. And so this is equal to 1/10 sine of 5 theta plus 1/22 times the sine of 11 theta plus c. And I started with integral in terms of theta, and so that is my answer. If I take the derivative of this and apply trig identity, I will indeed get cosine of 8 theta times cosine of 3 theta.